All right, here we are on Explore number 2. How is an orbital diagram created? Today is 10/29, Sunday 10/29/23, and we'll just draw our Cornell note lines. Hopefully you're using these now, writing notes to yourself and making connections to your learning. How is an orbital diagram created? Hopefully as we go through this, a lot of this will be familiar material. Sections here, visualizing electron configurations. Okay, I'm just basically taking a look at our sections here. Oops. Clear screen. Sorry about that. Filling an orbital diagram. Looks like we got 2 sections that we're going to want to make room for in our notes, and that's it. This should be a pretty short lecture here. So Roman numeral 1. There you go, visualizing electron configurations. Now, we've been breaking into this chapter and we've talked about electron configurations, the quantum numbers. You got your n equals 1, which had the 1s2. You had the n equals 2, which had 2s and the 2p's. Hopefully that's what's coming to mind right now. You should always be kind of thinking ahead, anticipating what you're going to read. When we take a look at this very first paragraph, you can see in green here, in atoms that have electrons in more than 2 energy levels, the order in which orbitals are filled is more complex. In these cases, an orbital diagram is helpful. Okay. Let's go ahead and, take advantage. Oh, that's interesting. That didn't actually pop up anything there. I wonder if I need to actually get out of tablet mode. Yeah. And here we go. We have our orbital diagram. What is it? An orbital diagram depicts an atom's configuration of electrons within successive energy levels. Each orbital is filled so that lower levels must be filled before the upper levels. Aufbau principle, right? Also, all empty orbitals in a level must be filled with an electron before an orbital can have 2 electrons. Hund's rule, right? We've learned both of these. The 2 electrons in an orbital must have opposite spins. Okay. Familiar territory. Definition here. Let's just go back over here. Sorry about that clear screen. And go back here. Let's check this details. A diagram used to illustrate the configuration of electrons within the orbital in an atom. Electrons are represented by arrows pointing up or down in the boxes representing each orbital. All right, I think that should work there. A diagram used to illustrate the configuration of electrons. And let me just downsize that and downsize that. And a orbital diagrams. These are what? It says helpful. When are they helpful? When you're dealing with more complex type of electron configurations. Okay, these are helpful when dealing with more complex electron configurations, i.e., more than 2 energy levels. Okay, and what do we do here? We got a picture over here. When diagramming an atom's electron configuration, orbitals are filled in order of their energies. Okay, so the diagram is filled in order of their energies. This was Aufbau principle, right? Comma or semicolon. And what else did we say? Boxes are filled 50% before going back and adding the second electron. And that was, of course, Hund's rule. And arrows depict the spin, right? So if we wanted to do a real fast drawing, we could go ahead and do something like that. We could it's basically just mirroring that picture that you have on Explorer number 2. You had your 1s level. You had your 1s. You had your next level was your 2s and 2p, right? You then had your next level up, which was your 3s, your 3p, then you had your 3d, and that one had 1, 2, 3, 4, 5, and on, right? But you recognize this table. We've been working on it in class. Okay, within an energy level, I'm right here now. Within an energy level, the higher the azimuthal quantum number, the more energy in the orbital. The 2p orbitals are slightly higher in energy than the 2s orbitals. Okay. So within an energy level, the higher the azimuthal quantum number, the more energy. Let's write that down. Okay, that sounds like a pretty important fact there. And we're going to make this number 2, okay? Number 2. And let's also just make sure we're continuing our line down here. Within an energy level, the higher the azimuthal quantum number, the more energy in the orbital. And they go ahead and talk about that here. where they say the 2p, which has an azimuthal number of 1, has a higher energy level than the 2s, which has an azimuthal number of 0. So we could say 2p is greater in energy than 2s. And the azimuthal number, we could say azimuthal number equals 1 here, and the azimuthal number here is equal to 0. Okay, if you recall that from the last chapter. If not, you might want to go back and refer to that. The differences between the energy levels generally decrease further from the atomic nucleus. That's an interesting point. Okay, so let's go and write that down as well. Okay, 3. The differences between energy levels decrease further from the nucleus. And I guess if you were to go back up to this drawing here, you could say that as you get further, as you move, let me use a different color pen here, the differences decrease the further away from nucleus. So we could say that versus if you were to say the differences, say over here, right, where you have bigger differences. So this versus this, because the 1s is very close to the nucleus. Okay, and we could just say that here. The 1s is closest to the nucleus. Okay, so that's kind of what that's saying there. All right, let's go on here. Go back to our mouse. You have some additional reading here. I'm going to just draw your attention to that. This is additional reading. And for those of you who are trying to figure out how to be to get the very best grade you can, this is how you do it. You make sure you do all the additional readings because there's always additional information in there that you can glean. Okay. You have a simulation here. This simulation is something we've done before. If you need to revisit it, then revisit it. Revisit if necessary. Right? Practice makes perfect. And we did this simulation last chapter. Okay. So moving on down, when filling an orbital diagram, remember the following. Fill the lowest energy level, energy orbital that is available. We know that. Place one arrow in each orbital of the same energy level before putting pairs of arrows in any orbital at that level. All the single electrons should be showing having the same spin. Remember, we do the up spin. So here we're basically saying that if you're going to fill out the 3s level, you would go like this and then down. When you get to the 3p, you'd go up, you'd go up, you'd go up. Then you could come back and do the second set, right? And that's what that's saying in number 2. If two electrons share an orbital, they must have opposite spins. We showed that there, right? Opposite spins, right? Okay. And this was Aufbau principle. And this was Hund's rule. Hund's rule, right? I know they're being fairly repetitious here, but that's okay. And we'll look at that. That's really all we have for lecture number 2. So what I want to suggest here is this. Let's go and write ourselves a summary sentence, okay? Or maybe a summary paragraph might be appropriate. So just draw a line here and write yourself a summary sentence or sentences. Okay, I'll be looking for that when I grade your notebook. And remember, don't shortchange yourself. Don't take shortcuts and